I need to first apologize for the length of my title. I know you're supposed to have nice, tight titles for your presentations, but I felt it was really important to have full disclosure. I don't often present to groups of planners, and so I wanted people to know right up front that this talk is going to be a little bit about science, a lot about mapping, and a little bit about biodiversity. And so you guys read the title. If you're here and you're bored, that's on you. Okay, so why mapping? So one of my favorite quotes about mapping, and the why I think it's really important, is because maps are like campfires. This is from the Sonoma Ecology Center. Maps are like campfires. They encourage people to gather around, look at complex issues, and work together to make decisions that work best for the land. And in today's environment, we're really getting data-driven. The City of Edmonton is moving to more of a spatial analysis approach to really assessing how our city building is doing. And so maps are key for communicating that to people, whether it's planners, the citizenry, councillors, basically a number of people. And maps are the common language that people can understand complex issues around. So why track our natural assets? I probably don't have to tell everybody here, you've probably drank the Kool-Aid like me, that they're a valuable part of Edmonton's landscape. They're some of our richest and most biodiverse areas in any municipality. And so people have heard of multiple ecosystem functions, like for biodiversity, they're important for biodiversity, for wildlife habitat and areas for native plants to thrive. They're important for soil formation, nutrient cycle, a variety of water quality related services such as flood protection cleaning out our water. And then of course there's all the community benefits such as mental and physical wellness. They've been doing more research on the mental wellness aspect, and they found that you actually put people 20 minutes in a downtown environment with no vegetation, and you put other people for 20 minutes in an area with lots of trees or an urban park, and they find out that the ones who have spent 20 minutes out in nature make better decisions and have lower stress levels. And so there's this mental wellness aspect of natural areas that are important and is often overlooked. Now, an interesting tidbit of information I found out yesterday, as you guys look at your plates, an example of some important ecosystem services is that about a third of your plate wouldn't be there if it wasn't for pollinators, such as bees and other insects. So this was on the federal website, so it must mean it's true. I don't know how they calculated it, but I trust my federal government. So threats to Edmonton's natural assets, what are they? Basically, habitat loss and fragmentation. Those are the key items that affect urban natural areas. This is work that was done in 2001. The boundary that you're seeing right here is Edmonton circa 1924. The areas in red are all of the wetlands and streams that have been lost between when when the city was founded in 1903 to when the study was done in 2001. So this is really significant, and there's estimated 90% of loss of our wetlands and our drainage courses in the central part of the city, and it's not much better as we move further out of there. Now, the important thing to notice is we're actually having to go back and reinvest a lot of money to recreate these systems. So this is the Lindrum Park, Lindrum Dry Pond / park. The city just spent $3.5 million retrofitting it into a dry pond so that it can accept all of the water that, if you could notice, that little stream was built over, and so this Lindrum Dry Park is a perfect area where water is flowing, and we need an area to capture it and then to take it out of the urban environment. So we're finding that these ecosystem services that are lost, we're having to go back and reinvest in them. So Edmonton has a long history of natural area tracking, and in Edmonton's definition, a natural area is basically an area of land or water that's dominated by native vegetation or naturally occurring patterns, and they encourage natural processes to take place. We have a long history of mapping. It started in 1986. These were hand-drawn maps done by Ely. Over 1,000 natural areas were mapped out, of which were identified, of which 32 were mapped in this type of sketched. People will notice, I don't know if you know Pilot Sound, and this is the Ellerslie Lake down on 23rd. So we've known about a number of our natural areas for a while. Now, in 1993, Council supported the mapping out of natural areas. This is what some people consider the city's Bible around where our natural areas are. It's GOS 1993. This inventory built on the first. And Council defined what the city views as environmentally sensitive areas, significant natural areas, and all other natural areas. Now, those other natural areas were just actually points on a map still, so we still didn't have a good inventory of all of our natural areas across the city. Then in 2006, we filled that in, and we basically pulled out all of those points, and we actually put spatial files around them. So this led to a clear understanding of where our natural areas were. And at the time, as you learned in 2001, the city was starting to understand the magnitude of loss around our natural areas and our natural assets. So there was a public outcry, and what resulted was this plan, Natural Connections, which basically said that we've got 3 mandates: to secure natural areas. Once they're in the city system, we need to manage them. And we also have to encourage an engaged public so that they can help steward our natural areas in addition. Now, this was reaffirmed in 2010 when the city approved its existing municipal development plan. People don't know, but there's 9 strategic goals in the municipal development plan, and one of those 9 is actually talking about maintaining a functioning ecological network. And Council's direction was, up until that point, we had been really planning out our natural areas and natural area protection based on what's in the tablelands and what's in the river valley. But Council said we need a system that's greater than the sum of its parts. And so there's clear direction for a paradigm shift, where we stopped doing site-specific kind of a museum approach to conservation planning, which is like, oh, we've got a balsam poplar tree stand, check. Oh, we've got a spruce tree stand, check. Oh, we've got a class 3 wetland, check. To actually an approach that looked at the overall system and focused on an ecological network approach, which comprised of core areas and the connections between those areas. Now, with this complete inventory that we had in 2006, the tablelands became recognized as important components of the city's ecological network. This is the ecological network that is outlined in the municipal development plan. So you obviously have your North Saskatchewan River Valley and its ravine systems that kind of create the bulk. But we also have connections into our tablelands, which is everything above the river valley, and connections with semi-natural areas to try to maintain that ecological connectivity. So from this, our work moved from just mapping out where the natural areas are to monitoring, attempting to monitor where our natural assets were at. And with monitoring, we basically found what we found in 2001, loss. So this is a natural area out in the western part of Edmonton. The road you see going north and south, that's 199th Street. Some people have their favorite golf course in this area. And so we just tracked from 2006 to now, where the loss occurred in that area. But what was really disturbing, we understood we're in an urban environment, we're going to have some loss, but what we actually were surprised about is even our great inventory that we thought we had wasn't helping us understand what we lost. We understood where we lost it, but not what we lost. So this is Sexy Natural Area Northwest 7009. It's an environmentally significant area. And it actually had some very unique vegetation communities, black spruce larch and marl pools, which are kind of deep pools that have a lot of calcium, that take up a lot of calcium from the geology underneath them, and it makes them very unique. Now, all of that red, we had no idea. Did we lose a marl pool? Did we lose the larch? What did we lose? So in 2010, we realized very quickly that we basically needed natural area monitoring research. It was a high need area, and that we had very little in place with respect to biodiversity monitoring. Sure, natural area loss, but not biodiversity loss. So in 2010, we attempted to use the newest technology at the time. We attempted to do vegetation mapping using satellite imagery. We failed miserably. The greatest detail that we got is the difference between deciduous and coniferous, and a couple of high-level items like the difference between turf and everything else, turf and roads. And so that didn't really work for us. And we were also left with no natural area information for surrounding municipalities, which, the City of Edmonton takes a lot of pride in our ecological network approach. That's hard to take pride in when you actually don't know what you're connecting to outside of your own borders. So we needed an inventory framework that could help achieve the city's natural area and ecological network goals. So we scratched our heads a little bit and we were like, well, let's go back to our policy. So C531 is a policy that was approved back in 2007 when the city did that big paradigm shift. And there are 3 key things that council directed administration to do. And I'm going to walk you through these 3 and identify how it relates to the tool that we needed to develop. So the first one is that we had to plan our cities so that ecological systems could function effectively at all scales, at the neighborhood, at the city level, and regionally, for regional planning. So it needed to be, our tool needed to be replicable so that if you planned in McConaughey, you'd have the same principles when you're planning in Dakota. It also had to be scalable, so you could talk about how those 2 neighborhoods were connected. So just an example of what scalability of the network looks like. This is McConaughey, one of our first neighborhoods that was designed using an ecological network approach. You can see there is a long linear natural area that was protected through the center. Right here, a couple of natural wetlands. Shaughnessy is in the bottom and center there. And we also connected to semi-natural areas, so parks areas. We retained a lot of the actual natural tree stands. So that's using the ecological network approach. Now the key thing is you can't leave it in isolation. You have to understand how that links into the city's ecological network and how that relates into the regional and so on and so forth. So it means that the ecological network model works at multiple scales, and it promotes systems thinking and intergovernment coordination. And the government of Alberta actually has a long history of doing these types of models where, I don't know if people know the grassland vegetation inventory and the Alberta vegetation inventory. These are all systems. They've mapped out about 3/4 of the province. When it comes to urban areas, though, they consider them big black boxes where there's basically industry and residential. Not a lot of natural areas in between. So we wanted to change that. Now, the second item that council directs administration to do under policy C531, which is our natural area systems policy, is that we want to conserve our natural areas to discharging their actual functions. So this was the map that we had of the natural areas at the time. Their functions, in order to figure out the functions, I would have to put an aerial photo underneath that map and go, oh, that green bit is wetland, versus that red bit, which is our conserved tableland areas, is a tree stand. So it was really done not very effectively. So we basically needed to ensure that our tool provided a framework in which we could set a baseline and also monitor, track basically biodiversity values and ecosystem values through time. Now the third thing that council directed us to do through the policy was to require ecological information to support planning and development applications. And we actually do that a lot at neighborhood planning and area structure planning. We have something called ecological network reports. However, when we get those reports in, it's done by a number of consulting industries and developers, and the city never provided a clear kind of communications framework on how we would like things mapped out. In some, we get very detailed information about the proportion of different types of species. Others, we just get species lists. And it's really not using the same language in each of our neighborhoods. So what we wanted to do was use the information and use the multiple years of experience that the province has and adapt some of their vegetation monitoring information systems into an urban environment to say, hey, we're not black boxes. We actually do have some valued natural area assets that we have to start monitoring. So the province's system they've created in 2013 is called the Primary Land and Vegetation Inventory. Now this is for all the areas in the province that are not green and not grasslands. But we use this because it's an air photo based and spatially referenced digital inventory. So basically using our stereoscopic imagery through the city, we can identify the information that's required for the system. However, because we're an urban area and we can get to a higher resolution, we actually say we improved upon it. We used to call this the uPLVI plus. I don't know how our province partners agreed like that, but I always like to rub it in. So we had increased resolution. We actually had field verification because we could go out and actually see what's out there. And we added site types specific to urban settings. So this is our old map where the green areas are basically a presence absence. Green, there's a natural area. Yellow, there's not a natural area. green, we don't really know if it's a wetland or anything. And in the yellow, we'd have to use our zoning maps and those types of things to identify what potential land use is there. And then, of course, we've got nothing in the intermunicipal buffer. So we go from this, applying the framework of the uPLVI, which we developed in conjunction with the province, and we go to this, where it's a detailed ecological inventory with multiple attributes within each of our polygons. And the main level of classification is linked to the ecological site phase. This is where the science comes in. And that's linked to the provincial eco-site guides and manuals, if anybody knows. It's basically a way of classifying vegetation communities and how they're driven by soil, moisture, and nutrients. So what does this mean? This is a traditional provincial PLVI. I don't want you to read the details. I just wanted to show you that we modified it to have 11 more site classes that are specific to the urban environment. So you can see we've now got acreage subdivisions, farmyard acreages, nurseries and tree farms, agricultural tillage sites. So that's where we've got our wetlands that are often sometimes tilled through. Maintained grass, transplanted tree sites. So all these things that at the high level provincial really is not as difficult to map. We can actually get a greater resolution here in the urban center. So what this looks like, okay, so I just told you a whole bunch of things about attributes, but what type of information can you get out of this? Now before, if you had a red polygon there, you'd say, oh, that's a natural area. We don't know what it is. But in our new system, that polygon, 7664 or something, 7597, the database shows that this is a forest stand dominated by balsam poplar. It's in breakup, so it's old, which is important to know for management because that's an older stand. There might be some hazard trees. And there's 10% anthropogenic disturbance. So this is erosion probably caused to trails. Now the total vegetated cover, which the city has policies to increase our vegetated cover to 20%. Well, this polygon is a class C, which means it's around 51 to 70% vegetated cover. And we also have some information about soils. So before we went from natural area, yep, there's a natural area there, to much more detailed information. So here's just a quick summary of the results. So across our study area, which includes a 3.2 kilometer buffer around Edmonton, and why 3.2 kilometers? That's 2 miles. And so we covered about 12 townships. We have over 1,000 polygons per township. The reason why I mention this is because the standard traditional provincial inventories give you about 150 to 500, generally more closer to 250. So the uPLVI is simple, basic. It divides the world into what's vegetated and what's not vegetated. So in our study area, you have 40% that's non-vegetated, so those are obviously our developed up areas, and 60% is vegetated, whether or not it's agricultural or natural area. So of the vegetated areas, this is how it breaks out. You have 80% has been modified. And the rest of it, 20%, would be considered your naturally wooded, wetland, and naturally non-wooded. Now we have some areas that are naturally non-vegetated. So these are our water bodies, slumping in the river valley, sandy, exposed side slopes, but 94% of our unvegetated area is understandably developed. But our new classification of natural areas means that in our database we can automatically pull out those natural areas. So we actually went from a system that just mapped out natural areas and had no information in the matrix to now having complete and total citywide coverage, including a 3.2 kilometer buffer, and we know exactly every square meter of the city and what it's based, what is in it, vegetated wise. So in our study area, we've got 13% of the area is in upland, so that means it's not wet. In Edmonton, that's about 11% of our area in terms of natural areas, and about 3% wetlands. Now, this is just the vegetated area, so this isn't the developed areas. In the vegetated areas, you can see that annual crops really dominate, makes sense, in our outskirts. And all of the colors on the right-hand side of the screen are basically all of our natural areas. But in addition to having that forested site, remember in 2010 we tried to do some satellite imagery analysis and we basically got deciduous and coniferous. Well, using this system, we actually now have a clear understanding of where our tree stands are and what they're dominated by. And so in this case, people aren't surprised. Edmonton's dominated by trembling aspen and balsam poplar. But if you'll notice on the very right-hand side, That's our larch and black spruce, the stuff that we lost way back in northwest natural area that I talked to you earlier. Now we know we don't have very many of them. So in terms of planning, when those pop up on our sight lines, we're like, oh, you know, we don't have that many of those. Let's see if we can find some way to incorporate them into the neighborhood.